In this video, we will discuss matrices in SageMath. We'll start with a vocabulary overview to get on the same page. Then we'll discuss how to make matrices and vectors in SageMath, store them into variables, do some operations with matrices, some of the special matrices that SageMath offers built in, and then we'll close with accessing an element of a matrix with an index expression, which, as you'll see, is actually not a very intuitive thing in SageMath. One note about this tutorial: much of what we cover could also be done in SageMath using the NumPy library, but as I'm intending to do some separate videos on NumPy in the future, today I'm only going to be discussing how to do the aforementioned topics using SageMath itself. Also note that I am running SageMath from cocalc.com from my browser, but what we go through today will work just as well if you are using SageMath downloaded directly onto your machine. First, let's do some quick vocab. So, I might not revisit all of these terms in this video, but I do want to run through them. A matrix is a rectangular array of numbers arranged in rows and columns, like so. You would usually think of it as rows by columns, and the order of a matrix is the number of rows by the number of columns. So for example, the above matrix is order 3 by 4. You'll often see this abbreviated as M as in Mary by N as in narwhal. So M by N, and you'll see this is a 3, 1, 2, 3 row by 4, 1, 2, 3, 4 matrix. It is important that it fits into this rectangular array, otherwise it won't work. A vector is a matrix with only one row or one column. An element is a number that's inside a matrix. So for example, here I have highlighted 23. 23 is one of the elements that's inside this matrix, as is 8 and negative 48. They're all elements. And the same is true for a vector. These are all elements of the vector. A vector can either be a row vector or a column vector, and a scalar is a matrix with the order 1 by 1. So here we have 8, but not the integer 8, so to speak, but rather the matrix with the order 1 by 1 of 8, which is a scalar. Okay, so with that out of the way, how do we make a matrix in SageMath? Now I'm going to actually delete this out using the key DD on my keyboard, just to give us some more space. So, to make a matrix in Sage, we can use the function matrix, like so, and function, for those who are just getting started, will generally be the name of what we, the name of the function followed by parentheses, and then you often put something inside the parentheses called an argument. In this case, the function is called matrix with the parentheses, and a function is just when you want to do something. It's like a pre-written bit of code that does something, so to speak. So we'll use this function matrix, and actually a capital M will work as well, but we'll be using the lowercase m. And inside these parentheses, you can put a couple of different things to make a matrix. First, let's keep it really simple and use the bare minimum. Let's put inside these parentheses a set of brackets, and then inside these brackets, let's put another set of brackets, which is what a row of our matrix will go into. So 1, 2, and then separate that bracket with a comma with another bracket, 3, 4, 5, 6. What did we do here? Well, notice a trap for the unwary. We actually put an outer layer of brackets over the whole thing, because this is what is going to ultimately be inside of our matrix. It's the brackets are a way of saying these are going to be the elements that are inside the matrix. And then we put in another set of brackets each row. So each row is contained in its own set of brackets, divided by columns with a comma, and then each element within that row is itself divided by a comma. So we'll run this by using on our keyboard Shift Enter to run the cell, and you see there is our matrix with its 3 rows with 2 columns. It's a 3 by 2 matrix, and each row it's 1, 2, 3, 4, 5, 6, and that's our matrix. Another way to do this very matrix, another way to write this same thing is to do matrix. It's the same function. And then inside these parentheses, instead of just starting with our matrix, let's put as our first arguments the order of the matrix. That is the number of rows by the number of columns. So in this example, recall it was 3 rows by 2 columns. So let's do 3, 2, comma, and then put in brackets our list of our elements that will go inside this matrix. And notice we aren't going to have to separate them any further. We can just do 1, 2, 3, 4, 5, 6. And whereas here we had split it up by rows with these brackets, if we write it this way, because we have the 3, 2 here, SageMath is smart enough to know that this is going to have 3 columns, 3 rows rather, and 2 columns, and it's just going to divide this up like so. So when we run it, it's going to do the same thing. And this is really nice. If you want to change it, you can actually do 2, 3 instead, and now it's going to have 2 rows with 3 columns. And you see, it would have been much more difficult to do that kind of manipulation if we had written it this way, because I would have had to delete out all those brackets and put them back in. So this way is much cleaner. The downside of this is you do need to know in advance what the order is of your matrix. And so if you do something that is not going to fit into a neat rectangle, like 3 by 3, it's just going to throw you an error. It's going to say, that's not possible, what are you doing to me? Okay, and so here, though, you see it works fine. So this is the same output as we had before. These are both the same matrix. It's just 2 different ways of putting the putting the same thing. If you want to make a vector that is a matrix of just 1 row or just 1 column, you can do that with a different function called vector. Parentheses, inside the parentheses put brackets, and then whatever you want your vector to be. If you run it, you'll see that SageMath will default to be a row vector, but if you want to hard code it as either a row or a column, you can do .row for a row or .column for a column. And you might be asking, why would you do .row if it's defaulting to be a row? Well, actually, SageMath is smart enough to know if you don't have this .row or .column and just have it as is, it will read from the context whether it's supposed to be a row or a column and predict which is the better vector to use, which can be extremely important with, especially with multiplication with vectors. And so if you want to just let it be as a vector without specifying row or column, you can do that, and it will make the decision for you when it comes time to do so. Or you can say, no, I really want this to be a column, and as you see, it makes it a column. Going back to matrices, there's other arguments that you can put in your matrix. So you can, at the very start of your arguments, put in the type of data that would go into the matrix, what's called a ring. And a ring is a mathematical construction in which there are well-behaved notions of addition and multiplication, which I know is a mouthful, but you can think of it as things like integers or complex numbers. And in fact, we're going to run through some examples just to illustrate what happens when you set different rings to your matrix. So let's go with a few of these. Let's do matrix ZZ, 3, 2, and then 1, 2, 3, 4, 5, 6. And I'm going to copy this, and I'm actually going to add a bunch of cells so that we can do a few of them. So let's see, we have ZZ, let's do QQ, and don't worry, I'll explain what all these are. Let's do RR, and let's do CC. And I overshot a little because those are all the ones that we're doing, though there are more in the documentation if you're interested. So what do we have here? Let's run through these each one by one, and we'll run them as we go through them. If you have ZZ, you are saying that everything in this ring is going to be an integer. So let's run it. Runs fine. But what happens if one of your elements is not an integer? Say you have 3.3. It gives you an error. Okay, so it's not going to convert it for you. So what if you had 1/3? It gives you an error. Okay, so you do need to know somewhat in advance what is going to be inside your matrix. QQ is rational numbers, so numbers that either stop or repeat a decimal, unlike pi or e, which go on forever. So here you see it works fine, and you could even put in, let's do 1/3, so that's 0.333 repeating, but it is in fact a rational number because it repeats. But if we try to throw in pi here, it's going to give you an error because pi is not a rational number, and the QQ leads SageMath to expect that you're only going to have rational numbers inside this matrix. RR is real numbers. Notice something interesting when we run RR with Shift-Enter like so. It actually gives it out with these decimal values. So if we put 1/3 here, which we saw earlier when we did QQ, it just kept it as a fraction. But here with RR, the 1/3 you'll see is actually going to give you this 0.333 repeating. And here, if you do pi, it does it no problem. It just converts it to a decimal value, the 3.14, etc. Next, we have in our last example, CC for complex numbers. Now, if you run it with a bunch of non-complex numbers, so to speak, it'll work fine because you can think of these all as numbers with a real part and then a complex part of like 0.0 times the imaginary number. And so you can, however, add into this some complex numbers and it'll run just fine. So if you do like 4 plus 3j, j being one way to write an imaginary number, and it's how it's done in Python, so it's how I'm used to it. You could use I as well, I believe. But anyway, so 4 plus 3j, and you'll see here it is 4 plus 3, and it did convert it to an I for me, but it works just fine. And so it's a little big to see, but it works just fine, versus here, if you had it in your RR, right, that shouldn't work, and it doesn't. It gives you an error. Okay, good. Well, you might ask, what ring is used in some of these earlier examples, and let me clear out all this with DD. You might ask, what is used up here when we have things like 1, 2, 3, 4, but we do not have a ring designated? Well, SageMath is going to make its best guess based on the elements in the list. So the documentation does recommend specifying your ring, but the examples that we will be using going forward are fairly simple. So going forward in this tutorial, we will probably not be specifying a ring and just letting SageMath make its best guess. But I did think it was important to tell you, because if you really want to have, rational numbers or real numbers or complex numbers or something specific in mind, depending on what you're doing, you do need to make sure that that's clear to SageMath by specifying the ring. So like here, it's integers with ZZ, for example. But the examples going forward, we're just going to let SageMath make its guess. Okay, so let's clear out some of this. So we have, for example, a matrix that's in a cell. Well, fine, that and a nickel will get you a cup of coffee, but how do we store this matrix we made and use it later? We can store it inside a variable, just like you can store strings or any other data inside a variable in Python or in SageMath, and that's with an equal sign. So a commonplace notation is to assign a capital letter to denote a matrix, such as A, and then the equal sign to is just our way of saying we're about to store something inside this variable, capital A. Don't feel beholden to that. You can certainly give a more descriptive name. It'll work just as well. So if you wanted this to be, you know, my cool matrix or something, like cool matrix, and then store the matrix inside that, it'll work just as well. But the more typical notation you see with matrices when you write by hand is the capital letter, so that's going to be a pretty typical way that you'll see people denoting their matrix. And that's what we're going to use. So then let's put in our matrix, and let's do the following one that we will use later. And I just have it on my other monitor here, so let's copy paste it in. As we see, we have A equals this matrix, and I just did Shift Enter to run the cell, and you'll notice that that does not output the matrix like we had before. It just stores the matrix. That's all we're instructing it to do, is to store the matrix inside A. If I want to see it later, I can do a couple of things. I can either put A in at the end of a cell, and it'll output it, but you might know this in SageMath, it'll just output whatever's at the end of the cell. So if you have 2 plus 2 here, now all of a sudden I'm not seeing my matrix anymore. So you can use a print function like you would with, again, this is just something from Python, print, to just be sure that you're printing out your matrix, which is just print with these parentheses is just saying, hey, give me as an output whatever I have stored inside this variable, whatever I'm putting inside the parentheses. Okay, so what did I do? I stored my matrix inside A, and I saved it for later using the equals sign. And now let's do a second matrix, and let's call it B, just because we're going to be playing with these. I did a little prep work here, and I have it in my other monitor. So let's now store B, and notice, fun fact, I went ahead and did 2 different means of writing the matrix here. Here we have the brackets, so it's just bracket by bracket for each row, separating them out into columns, and here we're specifying the order, but you'll notice that both of them, if I do print A and print B, you'll notice that both of them are 3 by 4 matrices. That's a little ugly. Let's do it like that. Okay, so if we have A, you'll notice it's 1, 2, 3 rows by 4 columns, and same with B, even though I wrote them in different ways. So that's just something to take note, and I did that on purpose because we are about to add them together. So you can do different operations with matrices very easily by using your variables as a stand-in for the matrices. So if I wanted to do A plus B, for example, I could do A plus B, and it'll run just fine. The spacing doesn't matter if there's a space after the plus. It'll work just fine, and the element by element addition is how it works. I believe I have a picture. Yes, so as you'll see, here we have the matrix A and the matrix B, and in fact it's 8 plus 4. You just add each element together. So 8 plus 4, 7 plus 6, 2 plus 8, all the way down to 29 plus negative 93, which you'll see is the same thing as 29 minus 93. And it's just really each element to its corresponding element, and that's all. That's all there is to it, though these do need to be the same order. They need to be the same rows by columns. Otherwise, it's not going to work for you. Okay, and so that's, and you see it's the same thing, A plus B, 12 all the way to negative 64. Should be the same, 12 all the way to negative 64. It's the same, but much faster, of course, when you do it in SageMath. Let's also take a look at multiplying matrices, because that's much more complicated. As you see in this next picture, if we were to call these, I know that this isn't what B was before, but if we were to call this B, A times B, it's not just the same as doing element by element like we did before. You actually have to do each element in the first row of A. times each element in the first column of B added together. So it's 8 times 4, 7 times 483, 2 times 19, 0 times 11, all added together. And all that just for your first element of your new matrix 3, 4, 5, 1. So you see it's incredibly tedious, but I did write it all out by hand here. I do not recommend doing matrix multiplication by hand, because SageMath does it in the blink of an eye. And in fact, note that the columns in the first matrix must equal the rows in the second matrix, which is why I had to make a new matrix here. And also notice it's not commutative. A times B is not going to be the same thing as B times A, so that's just a little tricky thing, because you're probably used to seeing, 2 times 3 is the same thing as 3 times 2, but it's not so with matrices. It's not a commutative property. So I did make a new matrix here called C, so let me just copy paste that in. And let's do A times C. And you'll see we have, 3, 4, 5, 1, 329, 45, all the way to negative 1607. And it should be the same as the picture when we had it by hand. And it is 329 all the way to negative 1607. It's the same thing, but see how much faster that was. It's really incredible. And also, just remember when I said it's not commutative, if I did C times A, it's going to give you something completely different. So just keep that in mind. It's not the same. This is a completely different matrix than that one. Okay. So SageMath also has a number of built-in special matrices, so why don't we run through them? Not all of them, because there's so many, but let's go ahead and do some of the more common ones or more interesting ones. Let's do ones matrix, and I'm just going to write them out, and then we'll do them all. So let's do ones matrix 3, 2, 0 matrix 3, 2, identity matrix 3, and don't worry, I'll explain what's going in the parentheses here. And let's do one last one. Let's do random matrix, and you'll see this one's going to have a lot in the parentheses. It's going to have ZZ, 2, 3, well, I think we were doing 3, 2, x equals negative 10, y equals 10, and again, I'll just explain what all that means when we get to it. So, the ones matrix, 3, 2, as you'll see, it makes a matrix of all ones with 3 rows and 2 columns. As you might have guessed, the 3, 2 is the order of our matrix. If it was instead 2, 3, it would be 2 rows with 3 columns. The 0 matrix is just the same thing as your 1 matrix, but now with zeros. So it's a matrix of zeros, but with the order as specified inside the parentheses here. The identity matrix, this is a fun one. It was going to make a square matrix of zeros with ones in this diagonal formation. And what does this mean? Well, you know how any number times 1 is that number, so 1 is the identity, which you might remember from math class. Well, that's what this is, but for matrices. It's the identity, and the secret to its success is this diagonal of ones, which is why it really has to be square. So all you need is the 3 to show it's going to be 3 by 3. If it was, 5 or something, it would be 5 by 5. It works just fine, and so it still has that diagonal of ones. And finally, the random matrix, where I put all this pizzazz. Okay, well, as you probably suspect, this is going to generate random elements, and it wouldn't do to just say, hey, SageMath, pull me some random elements out of thin air. You do need to give it some more instructions to be useful. So recall ZZ, it's a type of ring, it's our integers, so I'm saying, hey, SageMath, I want a random matrix of integers. And you do, I believe you in fact have to specify a ring when you do a random matrix. And then what's this X and Y? Well, you also don't want to just say, hey, SageMath, give me some random numbers of any variety from any range. I think you could do that and it would come back with something, but you're probably going to want to specify what range you want, right? So here we have from -10 to +10 inclusive, and so that could include the -10 and the 10 as well. So let's go ahead and run it. And so you see it made a random matrix of 3 rows, 2 columns between the integers, -10 and 10, and it's a matrix of integers. If we ran it again, we would get something completely different, and here you see -10 is one of the possibilities. It came up right here. If you didn't have a y value, if you only put in x equals, say, 100, that's going to generate random integers between 0 and 100. So, as you see, if I did, like, 3 or something, it's going to do, I thought it was 0. Oh, it is 0. Okay, good. So, yeah, so 0 and 3, it's going to give you something different every time. It's just random. Okay. The last thing I want to go into is accessing elements of a matrix. Let's bring back our matrix A and recall that SageMath uses Python's syntax, and in Python you start counting elements of a list at 0, not at 1, and it's just as true with matrices, and this leads to something that's a little unintuitive, but you can think of this 8 that's in the top left corner as having the coordinates 0, 0. So when referencing the elements of a matrix in Python and thus in SageMath, you're going to start counting at 0. And that is something you're just going to have to get used to. So if we wanted to pull the number from what we humans would think of as the second row, third column, 1, 2, 1, 2, 3, so this number 23, you would actually do, and the way the syntax works is the name of your matrix, which is A, with brackets, and then the row, comma, the column. But you would actually put 1, comma, 2. And what's your output? It's that 23 you're looking for. If you did what would be perhaps more naturally, natural, and did 2, comma, 3, it's going to be 29. And what's happening here? Well, remember, you're doing 0, 1, 2, okay? 0, 1, 2, 3, and that's the 29. Versus if you do 0, 1 and 0, 1, 2, that's going to get you that 23. So you have to start at 0, and that's probably the hardest thing to make sure you're always keeping in mind, but it is important to think about. You can also use a colon to access a swath of a matrix, though as before, you're starting at 0. And there's a couple other tricky things. So if you do A 0, colon 2, that's A, the name of the matrix, brackets 0, colon 2. That'll give you the first 2 rows here. And you might be thinking, hey, isn't this 0, 1, 2? Shouldn't this be giving me all 3? Well, no, that's the other tricky thing. That's a little unintuitive, but it's actually giving you everything up to this number after the colon, not inclusive. So say you wanted just 7, 73, and 2, just the second column, that would actually be A, bracket, 0, and why don't I delete these out so we can see them next to each other. So what we want is the 7, 73, and 2, right? That's going to be A 0, colon 3, comma 1. Let's run it, and there it is. So you see how it's a little unintuitive, but it does get you there. 7, 73, and 2 is what the output is. Okay, and there's a few more tricky things with this colon, but it's in the documentation, so I do encourage you to look at that. And also, of course, with anything with SageMath, the more Python you know, the easier these concepts are going to be to wrap your head around. So I also encourage you to, if you haven't already, check out just some basic Python syntax tutorials as well. And so that concludes our video on matrices with SageMath. And if you got value from this video, please do show your support by giving the video a like. It does make a difference, and I want to thank you very much for watching.